In this video, we look at solving systems of equations by substitution. We'll use these two examples here for equations. Just a reminder that when we solve a system of equations, we're really looking for when the two, in this case, linear equations, when do they cross, when do they meet, what is the point of intersections section. And in order to look at this, let's just quickly look at the graph. We're going to do it by substitution, but we'll just have a quick peek at the graph to see what that looks like. So if we're going to solve this system of equations, we can graph the first line, it looks like that. We can graph the second line, it looks like that. And what we're really trying to do is to find out where these two lines meet, and we can see if we hover our mouse over top of the point of intersection, we can see that the point of intersection here is 1, 2. So when we solve a system of equation, we're trying to figure out where that point is, and at that point, the x-coordinate and the y-coordinate for both lines are the same. That might seem obvious, but it's a really important idea. So let's have a look at how to do this algebraically by substitution. The first step in order to solve a system of equations is to solve one of the equations for x or y. Now sometimes you'll be given the equations already solved for one of these variables. So for example, if one of your equations is y equals 2x plus 4, and the other equation is something like this one here, step number 1 is already done. We've solved, or we've been given, an equation that's already solved for us. That doesn't always happen, as you can see in this case. What we need to do is to solve one of these equations for one of the two variables. And there's no wrong answer here. You can solve in the first equation or the second equation, and you can solve for x or y. Sometimes this work is going to be a little bit harder than other times. We want to make it as easy as possible. So one of the things that we're looking for here is we're looking for a variable that does not have a coefficient. So there's no number in front of it. That's going to be easier to solve for. Again, you could solve for a different variable, but this is going to be the easiest one. So in this case, it's probably easiest to solve equation number, I'll label these equations, we'll call this number 1 and this number 2. In this case, it's probably easiest to solve equation number 2 for y. So solve, so this will be step number 1. We're going to solve equation number 2 for y. So here's our equation, 2x plus y equals 4. We want to get y on one side of the equation all by itself. In order to do that, we're going to get rid of that 2x. The 2x is positive. We can do that by doing the inverse operation, which is subtracting 2x. And when we do that, we will get the 2x minus 2x here on the left will be 0. We're left with a y here. And on the right side, we have 4 minus 2x. If you wanted to, you could write that as negative 2x plus 4. That's fine. That works. Nothing wrong with that. I'll leave it like this for now. All right, we did step number 1. I'm just going to change the label here because I realized that that looks like the same as we have over there. So let's talk about this as step 1 was to solve for one of the equations. Step number 2 is we substitute the value of that variable into the other equation. So what I mean by that is everywhere we see a y in equation number 1, we're going to substitute a 4x minus 2 instead. So step number 2, sub y equals 4 minus 2x. I think I just said that backwards, but there's 4 minus 2x into equation number 1. So everywhere we see a y in our equation, so here's our equation, 3x plus 5y, and I'll just do that y in a different color. That might be helpful. And that is going to equal 13. So that's our original equation, number 1. And everywhere we see that y, that red y, we're going to replace it. So 3x plus 5 times, and again, instead of y, we're going to substitute what we found in our equation up here. So 4 minus 2x, and all of that has to equal 13. So you can see our equation looks the same here as it does here, with the exception that we replaced y with this information here. So our next step is really just to solve this equation for x. So I guess that's step number 3. Solve for x, or whatever variable, in this case it's x. And in order to do that, we're going to expand, multiply through the brackets. So we're going to get 3x plus 5 times 4 is 20. So we multiply the 5 by the 4, and then we have to multiply the 5 by the negative 2x. 5 times negative 2x is negative 10x. That's everything on the left side. Now on the right side, we still have 13. We're going to solve this equation. Probably the first thing we want to do here is collect like terms. There's a 3x and a minus 10x, so 3x take away 10x is negative 7x. We still have the plus 20 on the left-hand side, so we'll leave it there for now, and that equals 13. All right, we have this linear equation. We're trying to solve for x. We need to get x all by itself. Let's undo this addition by 20, so we'll do that by subtracting 20 from the left, and then 20 from the right. 20 minus 20 is nothing. We're left with a negative 7x on the left-hand side. 13 minus 20 will give us negative 7. And then our last step here is to divide both sides by negative 7. That gives us x equals 1. So again, we found the x-coordinate where these two lines intersect. Our next step is to find the y-coordinate. I guess technically our last step here before we're finished. So let's find the y-coordinate, and we find the y-coordinate by substituting. So let's I got the wrong colored marker there. Substitute x equals 1 back into the equation where we solve for y. Now we could actually substitute x equals 1 into equation number 1, into equation number 2, but this one's already solved for y. We've already done the work to get here. Why don't we just go ahead and do that? Into y equals 4 minus 2x. So let's go ahead and do that. So we get y is equal to 4 minus 2 times, and we already said up here that x equals 1. So we'll substitute there. And now we just evaluate. Following order of operations, 4 minus 2 times 1 is 2. 4 minus 2 then is 2. So we get y equals 2. So our point of intersection, or our solution, so point of intersection for short, or solution, is going to be the point 1, 2. And if you think back to the graph that we saw, that graph had a point of intersection of 1, 2. So that's how we can solve a system of equations using substitution.